everyone, welcome to the channel Science Fast Track. Today we are basically going to study the concept of time dilation, and we will try to understand whether the time is an absolute quantity or a relative quantity. First of all, in the earlier scientific view, there was a famous scientist named Isaac Newton. According to Newton, time was an absolute quantity and a constant quantity. He believed that time flows the same for every person who exists in this universe. In other words, time is universal and it doesn't depend upon the frame of reference of the observer. Newton stated that time never depends upon the position or motion of the observer. No matter where you are or how you observe an event, time always passes in exactly the same way for each and every person present in this universe. However, after the 20th century, another scientist appeared who named was Albert Einstein. He presented the theory of relativity. According to Einstein, time is actually a relative property. This means that time can depend upon the point of reference of the observer. Einstein explained this concept with an example. Suppose we have an object. If that object starts moving with a velocity close to the speed of light, then in this situation, the time associated with that object also becomes relative. If we observe the time of that moving object from our frame of reference, we will see that its time is no longer remain constant. Instead, it becomes relative and depend upon our position. To understand this idea more clearly, imagine that we have two humans. Both of them are 5-year-old. Now suppose that one of these people jump into a spaceship and the spaceship start moving in a space with a velocity close to the speed of light. In this situation, when both people are moving away from each other, one on Earth and another traveling in the spaceship, time becomes a relative property. The person who remains on Earth is in the stationary condition or rest condition. When this person observes the astronaut who is moving with extremely high speed, he will for the astronaut. We can understand this in another way. If a certain process takes a specific amount of time for us on an Earth, then for the person in the spaceship, that same process will appear to take more time. If the second on our clock moves normally from one tick to the next, then the second on the astronaut's clock will take longer to move from one tick to the next. From our perspective, the astronaut's clock becomes slower. At the same time, from the astronaut's frame of reference, our time will also become slower. Now, suppose that after a long journey, the astronauts return back to the Earth. During the return journey, the astronaut's frame of reference changes. His perspective of observing time changes as well. At that point, from the astronaut's point of view, the clocks on the Earth will start moving faster. When both persons meet again, then we will observe that the age of the astronaut is much less as compared to the person who remains on Earth. This happens because all biological processes happen inside the astronaut also slowed down. This process is known as twin paradox. Finally, this theory was introduced by Albert Einstein. He stated that whenever a body starts moving with the speed close to the speed of light, then time associated with it also stretch whenever we will observe it from the Earth.